Welcome to this video. Up until now, we have studied the following methods of solving linear equations in two variables: the graphical method and the substitution method. Now, as we move forward, we'll study another algebraic method of solving a pair of linear equations in two variables, and this method is called the elimination method. Let's look at the linear equation in two variables made by Rahul again. Today, we will help Rahul in finding out the number of balloons and ice creams. First of all, let's make the coefficient value of any one of the variables, x or y, same in both the equations. For doing so, we multiply either of the equations or both of them by a non-zero constant and add or subtract them. You can see that it will be easier to multiply a constant in equation 1 because here the coefficient is 1 for both the variables. In equation 2, the coefficient of x is 3. Hence, in order to make the coefficient value of x equal in both equations, we will multiply equation 1 by 3. Can you multiply equation 1 by 3? Excellent! After multiplying by 3, we get 3x plus 3y is equal to 57, which can be represented as equation 3. Now, in order to eliminate x, let's subtract equation 3 from 2. Can you tell why we have subtracted these equations? Correct. If the sign of the variable which is to be eliminated in both the equations is the same, that is positive or negative, then we subtract one equation from the other, and if the signs are different, then we add both the equations. This eliminates one variable and gives a linear equation in one variable only. Solving further, we get y is equal to 12. Now, we need to replace this value of y in any of the given equations. Let's replace this value of y in equation 1. Solving further, we get x is equal to 7. Therefore, Rahul bought 7 balloons and 12 ice creams. Here, to solve a pair of linear equations in two variables, we eliminated one variable and found an equation in terms of the other variable. This is why this method is called the elimination method. In today's video, we learned how to solve a pair of linear equations in two variables by the elimination method. In the next video, we will look at some examples based on this method. Welcome to this video. In the last video, we learned how to solve a pair of linear equations by elimination method. Today, we will look at some interesting examples based on this. Solve the following pair of linear equations by the elimination method. Can you tell what is the first step we need to follow in the elimination method? Correct. First, we'll make the coefficient of any one of the variables equal. After looking at the pair of linear equations, you can tell that it is easier to make y equal as its coefficients are smaller as compared to that of x. To make the coefficient of the variable y equal, we need to multiply equation 1 by 3 and equation 2 by 2. After which, we get equations 3 and 4. Can you tell whether we need to add or subtract the equations to eliminate variable y? Very good. Since the variable to be eliminated has opposite signs, we will add both the equations. Adding equations 3 and 4, we get x is equal to 2. Substituting this value of x in equation 1, we get y is equal to 1. Hence, x is equal to 2 and y is equal to 1 is the solution of the given pair of linear equations. Substituting the values of x and y in equations 1 and 2 and solving them, it can be proved that x is equal to 2 and y is equal to 1 is the only solution to the pair of linear equations. In this video, we looked at some examples based on the elimination method of solving linear equations. In the next video, we will look at the commonly made mistakes while solving the linear equations by the elimination method. Welcome to this video. In the last video, we learned how to find a solution of a pair of linear equations by the elimination method. Now, we will look at some commonly made mistakes while solving such questions. Solve the given pair of linear equations by the elimination method. Pause the video to solve this question and then match your answer. In the given pair of linear equations, in order to eliminate one variable, when we multiply equation 1 by 2 and subtract it from equation 2, we get an equation with no variable. You must remember that whenever we get an equation without any variable in it, then there are infinite solutions to the pair of linear equations in that situation. Therefore, there will be an infinite solution to this pair of linear equations. Hence, option 3 is correct. If you selected option 1, then it is a good try, but it is the wrong answer. Because to solve the given pair of linear equations, when you multiply equation 1 by 2, you forgot to multiply y by 2 and solve the question further. As a result, ended up with a wrong answer. If you have selected option 2, then that's also a good try, but it is also the wrong answer, because to eliminate a variable in the given pair of linear equations, you multiply equation 1 by 2 and then subtract it from equation 2. Now, you forgot to change the negative sign to a positive sign on the RHS, because of which we get a false statement with no variable. This shows that the pair of linear equations does not have a solution. So I hope you understood why option 3 is correct and the rest are incorrect. A teacher can test his students in the class by using such examples.